Okay, so the problem we're investigating in the reactions lab, okay, is going to be that when substances are mixed, the chemical properties, not the physical properties, okay, influence or determine whether a reaction will take place. Okay, what evidence do we have that a reaction takes place when substances are mixed? And we talked about this the other day. What are the signs of a chemical reaction? Those are the signs that a chemical reaction has occurred. Okay, so I would say that those are something that should probably end up in your hypothesis, specifically in the then part of your hypothesis. They are the evidence that a chemical reaction has occurred. All right. Now, what I would say needs to go in the if part. I know I'm skipping the variables. I'll go back to them. Okay. But something that should end up in the if part of your hypothesis should probably talk about this part here, about chemical properties. Okay. I would say that finding a way to almost reword what's in that first sentence, okay, would be a good idea for the if part. All right, so in the if part of the hypothesis, then, we should talk about what determines or what causes a chemical reaction. And it says up here that that's the chemical properties. All right, so I would say that in the if part, you should probably talk about chemical properties influencing whether or not a reaction takes place. Okay, the and part is simple. You're just describing the experiment, so you can read through the procedure and give some kind of brief description of what we're going to be doing. It's basically mixing various pairs of compounds together. Okay, something I did notice, guys, and it did cost a few people marks in the first lab report. In the hypothesis, we're supposed to have if, and then, and what words are we not supposed to have? I, we, us, right? I had a lot of we in there, okay? We don't want to have reference to people, specific people. We want to make this experiment independent of the people performing it, okay? All right, for our variables, okay? The manipulated variable is the thing that we're doing different or changing throughout the experiment. Well, if we look at the procedure here, it says that essentially each time we're looking at a reaction, it's with different materials. Okay, it's a different set of materials each time, right? The first pair that you're mixing is A and B, right? So that would be sodium hydroxide and ammonium chloride, right? Those two will be mixed together as the first pair to show whatever signs that reaction will show, okay? And then the next pair will show different signs, most likely, okay? And things like that. So I would say, describe your manipulated variable. How are you manipulating it? Okay, so same as it was in the first one, right? So how is it being manipulated? Okay, and what effect is that going to have? Okay, people did a pretty good job of listing those two things in their lab reports, but I did have a few where people just wrote down, this is the manipulated variable because I'm changing it. Okay, again, that's not good enough. Okay, we need to have, here's how this is being manipulated and the effects that that's going to have. All right, I think the responding variable is fairly straightforward. I think you guys can figure that out, right? We're mixing different things together. I would assume we're doing something with that mixture after that we would probably want to record, and that would be our responding variable, right? Remember again to explain, so identify the responding variable, explain how it's changing, okay, during the lab. Controlled variables, how many of those? 3. I had a number of lab reports that only had 2. Do I need to explain each controlled variable separately? Yes, you can't say the same thing for all 3. I saw that a bit too, okay? Or it was, here's the 3 controlled variables and they're controlled because I'm keeping them all the same. No, each one needs this in its description, okay? How is it being controlled? Okay, and essentially why? Like what effect would it have if it wasn't? Okay, why is this being controlled? I'm controlling it this way. Well, actually, you wouldn't use the word I. It's being controlled in this way because it would have this effect on the experiment, right? That needs to happen for each of the 3 controlled variables. All right, we're kind of doing the initiating and planning right now. I think I put a chart in the lab template, right? Okay, so the chart you don't even have to make up. It's already there. But you need to have a paper copy of that to take into the lab tomorrow. So either print that at home tonight or make a hand-drawn copy of it. All right. Really, there's not too much there. It'll be, kind of a before and an after for each, pair that you're going to mix up. Okay, now, in terms of predicting the products, that's going to be a little bit new. In fact, it's what we're going to be working on the day after we do the lab. That was just the day I could get the lab where it wasn't booked. So we're going a little bit ahead of where we're supposed to be, right? But our reactions, when we do the lab, that's what it'll look like. Okay, we'll have the fluids will be in, or the solutions, will be in Erlenmeyer flasks, and they'll have eyedroppers in them. Again, do not mix up the eyedroppers. Okay, because if you take the eyedropper from one and put it in the wrong one, the reaction will take place in the sample, and I'll be displeased because I'll have to make the sample again. All right, so make sure that if you forget where you got it from, okay, just bring me the eyedropper and I'll get new ones. Okay, I tried one time to put permanent marker and write on the eyedropper where it came from, but then I had a bunch of people walking around with the names of chemicals on their thumb backwards. Course, but yeah. Okay, so that's where they'll be. You'll get a big watch glass this time. Okay, that's the one, if you watch the observations video for the first lab, you're going to do it in a big glass this time. All right, waste bucket. Everything goes in there when you're done. Okay, everything goes in the waste bucket when you're done. Rinse the thing with the wash bottles each time. All right, now, so the reactions that are going to take place are as follows. Okay, and I know we haven't talked a lot about predicting yet, so I'm going to kind of introduce it here, and then we'll see kind of what's going on. Can we tell what kind of reaction is going on just by looking at the reactants? Yeah, we can, because every reaction had a different setup for its start. All right, so in this first reaction, I've got 2 ionic compounds. What kind of reaction is that? Yeah, it's a double replacement reaction, or at least it's supposed to be. All right, it may not end up being perfectly the way we would predict it, and that's okay. All right, I'm not really looking at whether your predictions are actually going to be correct, as opposed to you did a pretty good job of predicting what should have happened according to what we've learned. Okay, so in this first reaction here, okay, who should switch places? Sodium and ammonium. Okay, remember ammonium is the only positively charged polyatomic ion, so it acts like a metal. Okay, so sodium and ammonium should switch places, so we should be able to predict who ends up with who on the other side. Okay, and what kind of reaction should number 2 be as well? Yeah, these are both ionic compounds. This is acetic acid. It's just written funny. Okay, it's written with the negative ion first and the positive ion second. Right, it's just a weird one. And then we have sodium hydrogen carbonate here, right? So they're going to react. So we would predict, again, what we think should happen. So we would switch the 2 positively charged things so they end up with new partners. Okay, pair 3. What kind of reaction do we suppose that's going to be? Double replacement. They both look like ionic compounds. So we can predict, again, by switching the metals, who should end up with who on the other side. All right, now pair 4 and pair 5, you don't have to predict those 2 because they involve an indicator called phenolphthalein. It's a complex thing that you don't have to even do until like Chem 30, if you even have to do it then. Okay, so you don't have to predict the products for those ones at all. So don't worry about them. Okay, and then for pair 6, all right, we've got, again, an ionic compound and an ionic compound. So what should happen there? It should be double replacement. Again, we switch the metals. Okay, and then number 7. Yeah, it looks like single replacement element this time reacting with a compound, so we can figure out what's going to end up or who's going to end up with who. Okay. Now, 2 of these reactions are not going to work out the way we predict them. All right, and there's no way for you to know that ahead of time. All right, but we will talk about it when we come back from the lab tomorrow, and I'll actually write out the reaction as it occurs. But I would like to see you guys try to predict them. Okay, the way we've talked about, okay, basically swapping the metals and things like that for the double replacement reactions. Okay, but I'll write out the full reactions for the 2 that do not go well. Actually, I won't write out the full one. I'll give you some tips and hints on how to do it. give you part of it. Okay? But that'll be something there, guys, that needs to be done as well. Okay, have those reactions predicted as best you can. I don't expect them to be 100% right at this point. Okay, we just want to try and predict them as best we can.
So what does RXN type mean?
Reaction type. RXN is shorthand for reaction. Okay, questions on that part there? Okay. All right, and then obviously you're going to have your observations chart here. I would say it would be a good idea in your observations to maybe do this. Before and after, so you got some comparison. You go into the tools and you go subscript. Yeah, look for subscript. Highlight the number you want to make smaller, and there's a shortcut key for it. It'll say that when in that menu. All right, so I would say probably a good idea to have your observations set up something like this, or just write it kind of anecdotally, like a paragraph at the beginning of the reaction that looked like this, and at the end of the reaction, this is what happened. Okay, however you want to do it, but make sure you reference the reactants and the products in your observations. Okay, so those are the observations that I made. All right, you don't need those yet. Okay, for the analysis questions, okay, the things you're going to have to do, and obviously you can't do this until we've actually done the lab, so don't try to do it until we've actually done the lab. Okay, using words and formulae, write out the chemical equation of each chemical reaction that occurred in this activity. Right, so that means write it out in formula form, write it out in words, balance it. Okay, identify the reaction type. Right, that's what we want to do for question number 1. So you'll have 7 of them. Right, and then for number 2. 2 of the reactions that you do in this lab are going to produce precipitates. What you need to do is figure out which of the products in those reactions were the insoluble precipitate that was formed. How do we do that? Yeah, use your solubility chart on the back of your periodic table. All right, so you've got the reaction all written out. You've got reactants and products. All you have to do is look at the products and find out from your chart which one's not soluble, and that will be your precipitate, right? So you guys have to show me that you can do that as well for question number 2. Pardon me? No, you don't have to predict which one would be insoluble ahead of time, just for question number 2. So you'd say in reaction whatever, this compound was the precipitate because the solubility chart says it's insoluble. Same thing for the other one, okay? There'll be 2 of those. All right, and then for the conclusion, again, copy and paste your hypothesis. Explain to me if your data and analysis prove it to be correct. Yeah, both. So I want a word reaction and a formula reaction for question number 1. Okay. All right, so make sure you get your conclusion done. The conclusions I've looked at so far were in general pretty good. People did a pretty good job of having a few sentences explaining why they accepted or rejected their hypothesis, and that's exactly what you should have. Right? Sources of error and evaluation, 2. Okay, figure out some sources of error that are inherent to the procedure. Okay, not mistakes that were made, just things that maybe could be improved or make your life easier if you were to do it again. Again, the class discussion doesn't need to be done. We'll go over those when I hand back the labs, which will be a week from, so the 26th. Yeah, I said it says the 19th there, but it's a week later. Okay, questions there, guys? All right, so you got a little bit of time here, not much left in class. You can kind of work on that, but that's the tips and hints that you're going to get pre-lab, okay, for the lab.